Okay, welcome back. It is early in the morning, so hopefully I'm awake enough to do this, but I am working on number 4 on the chapter 3 review, which is solving a polynomial equation. I am choosing to do the slightly easier version of one because I did the very hardest factoring one for you. Um, this is for part A. For part B is similar to this, it's just you've got polynomials on both sides of the equation. So instead of having a 0 over here, you've got a polynomial here and a polynomial here. So what you're going to do on that one before you do anything else is get it set equal to 0, right? So you're going to subtract the entire polynomial over here over to the other side so that you get it equal to 0, okay? Just wanted to kind of mention that uh, out of the gate as we get started on this. So we've got a polynomial here that we want to solve, and it equals 0. So when it equals 0, what you will want to do is you will want to factor this polynomial. And so essentially we're going to be doing the same thing we did in the last video, only this one should be a little bit nicer because it's uh, the degree on the polynomial is smaller. Okay, so again, I'm going to be checking for rational roots first to try and find some zeros. Well, that's the P over Q thing. So my rational roots are going to be P over Q, and P, this is a factor of, in our case, it's this term. Okay, so factor of -2. It really doesn't matter if it's -2 or +2. They will have the same factors either way. And then Q is a factor of 6. Okay, so those are the types of rational roots I can have. So my P, this can be, well, it's a factor of -2. So we could, 1 goes into 2 and 2 goes into 2. So we can have ±1 or ±2. Q, what goes into 6? Well, we've got, and again, you don't need plus or minuses on these ones because that'll just add a repetition to everything. 1 goes into 6, 2 goes into 6, 3 goes into 6, 4 doesn't, 5 doesn't, but 6 does. Okay, so those are our factors of Q. So now the possible rational roots, so possible rational roots are going to be, we do fractions of P divided by Q. So when I divide the P's by 1, right, this one here, we just get the same thing as we did before. So ±1, ±2. Okay, so now we've divided by 1 for Q. Now let's try 2. So divide ±1 by 2, we get ±1/2. Okay. ±2 divided by 2 is 1, so we've already got that one taken care of. We don't need to write that down again. Let's divide by 3 now, so we get ±1/3 and ±2/3. Okay. And then we'll divide by 6 is the last one we need to do. So ±1/6. And when I do 2 divided by 6, that's the same as 1/3, which we've already got. So those are my possible rational roots. Okay. So let's try and figure out a root of this so that we can factor it out and essentially find when this polynomial equals 0. So let's start with positive 1. That seems like a good place to start. When I plug in positive 1, I get 6 plus 1 minus 5 minus 2. And oh my goodness, we are so lucky. We got 0. Okay, so plugging in positive 1 worked. And so then I would do my synthetic division on this. Make sure too when you're doing synthetic division that if you ever have, like, if there's a missing term in here, like there's no x to the fourth or x squareds or whatever, you need to make sure and put a 0 in this, right? But for this one, we go from x cubed, so from 3, 2, 1, 0. Yeah, so we've got everything. Okay, so we bring down our 6 times by 1 is 6, add is 7 times 1 is 7, plus negative 5 is 2, and then times by 1 is 2, add is 0. Okay, so we've now got one factor out of this, which is awesome. Okay, and the new polynomial that I'm dealing with is 6x squared plus 7x plus 2, right? That's the new polynomial that I'm dealing with now. Okay, so let's try just again. We'll try positive 1 and see if it's a repeated root of this polynomial, but actually you can kind of see here all of these numbers here are positive, right? 6, 7, and 2. So if I plug in a positive number for x, I'm going to get out a positive number for y. So no positive numbers will be solutions of this anymore. Okay. So even if I plugged in 1, I would get 1. So 1 times 6 is 6, plus 7 is 13, plus 2 is 15. So that's not going to work. So we've exhausted positive 1. Let's try negative 1. So negative 1, when I plug that in, I square negative 1, I get a positive 1, minus 7 plus 2. Okay, that's not quite right. So negative 1 is no bueno. Okay. We already said that positive numbers won't work in this because these are all positive coefficients here. So positive 2 is not going to work. Let's try negative 2. So we do 6 times 4 plus 7 times negative 2 plus 2. So this is going to be 24 minus 14 plus 2. That's going to not be 0. Okay, so negative 2 doesn't work. So the only things we're left with here are fractions, which is always a fun thing to have to deal with. You could use the calculator to plug these in if you want, but I'll just do it directly. Let's try negative 1/2 now. So when I square negative 1/2, I get 1/4, so 6/4 plus, and then negative 1/2 times 7 is negative 7/2, and then plus 2. Let's see here, how many fourths? This would be negative 14/4. And then when we add that to 6/4, how many fourths is this? 8 fourths. Let's see, 8 plus 6, is that 14? Yes, it is. Okay, so this is actually 0. Good. So just adding, and you could throw those in the calculator to get decimal answers if you wanted, and just add them up and you'll find you get 0. So negative 1/2 works. which is awesome. Okay, so I'm gonna factor this. I'll use my synthetic division again, negative 1/2, 6, 7, 2. Okay, so I bring down my 6, times it by negative 1/2, I get negative 3. We add is 4, times negative 1/2 is negative 2, which is 0. Good. So, what is this what does this tell me? It tells me that what I'm left with here is really the polynomial 6x plus 4, right? And so what have I done is I've factored out from this polynomial, I factored out an x minus 1. You have to switch the sign on those when you're plugging them in, right? An x minus 1 and an x, well, it was a negative, so it's going to be x plus 1/2, and then a 6x plus 4 is how this is going to factor, okay? Equals 0, okay? And so now I know exactly what my answers are. They are, well, I set each individual piece equal to 0, so it's 1, which is actually the same as that number, right? Which makes sense because when you plugged in 1, it did work, right? 1, negative 1/2. And then for this last one, we want to figure out where is that last one equal to 0. Well, 6x plus 4 equals 0. We can subtract 4 over and then divide by 6. So we get negative 4 over 6, and that is negative 2/3. So those are going to be our answers here. Okay. So again, factoring is a kind of long, terrible process, but hopefully you're kind of getting the idea, reminding yourself how we did this from before. So hopefully that helps with that. The other one that they're having you do is a little bit harder because it has degree 5, so it's kind of a longer process. And remember, you need to subtract over one of the polynomials so that you get it equal to 0 before you kind of start factoring anything. But it's essentially the same sort of process as what we just did here. So, okay, well, I will see you in the next video.